Hey guys, welcome back. So in this video, let's continue our discussion on the PL-SQL topics. So in the last video, I did cover up to how functions work, right? So we did see how procedures work, and some sort of operations on procedures, and different variations in which we can write procedures, and then we see functions. So in this video, we need to cover two more topics. One is cursors and the other is the triggers. So let me start off with cursors. So we did discuss how to use cursors, how to create a cursor. Now, so and we have also discussed that we cannot write the cursors as an independent statement. Yes, we can create something called as an anonymous block and use cursors, but the best practice of using a cursor is to create a procedure, and I use a cursor to manage your own tasks, right? So let's create a cursor. Okay, let me open the query tool. Okay, so let's select this table. So we have this table, right? Yeah. So let's discuss why do we need something like a cursor. So in our previous video, I did discuss why we needed a cursor, and every every a transaction or every operation that we write on a DBMS will eventually create an implicit cursor, and it will be used by the DBMS software internally. But not every time that a simple SQL statement is enough for your processing. So sometimes you need to do something more than what an SQL statement would do. So if you want to do something more, if you want to customize the way SQL query executes in its normal flow, then you have to do it on. Okay, then you have to change its default functionality. So how can you change the default functionality? You should be able to capture how it is executing. So we can capture that using a by explicitly creating a cursor. So if we have the cursor, we have the record pointer with us, so we can do our custom manipulation on the record, right? So it enables us. So cursors are supposed to be used with the function, so that's the uh, best practice of using a cursor. So let me copy and paste a script, right? Okay, so this is a procedure. Let's look what this procedure is trying to do. So we are in create or replace a procedure. So the procedure name is get team players, and we are going to give the team ID, which is an integer. It is an in parameter. I think we have discussed what in parameters, out parameters are, right? And we are using the language PL-SQL, and we are defining the block. So this is very tricky. So now I'm going. So we have also discussed about this a declare session, right? So we are going to declare. So we are going to declare all the variables that we are going to use in this procedure. Okay. So I have a variable called as player record, and it is of a type record. So what is this record? See, so okay, in this table, if you look at this table, so this is okay. This is the entire table, and if you were to look at this single row, we define it as a record. So what is a record? It is actually a single instance. Okay, it is a single instance of a table. It can be of any data type as defined by the table, right? So we can define it in any way. Let's look at the okay. Okay, let's look at the other one. So here we're defining something called as a cursor. So we're defining a cursor. So we are naming the cursor as CUR, and it is of the type cursor, and we're using this keyword for to define what is the statement this cursor was supposed to execute. So we can provide any sort of DML command here. So this command will be used to understand what sort of operation that is being performed by the cursor, right? So we have defined a cursor, and there is something other. Okay, there are some other things we can do with the cursor. So uh, by default, a cursor is is a unidirectional. That means we can only move in the forward direction, right? Let's say our cursor is here, then it can only move to the next and then next and then next. But we cannot say, okay, if it is at 3 and I wanted to jump back to 1, then it's not a default behavior of a cursor. But if we want our cursor to kind of execute that functionality, we might have to define it in a way, saying a cursor which is a scrollable, right? It's a scroll. We can okay, there are actually many attributes that we can pass to it, but let's stick to a simple cursor. So okay, yes, so in this declare session we have declared a variable of type record and a cursor of type cursor, right? And we have defined what statement it was supposed to execute. Okay, fine. Now what should we do in the procedure? So we will begin the procedure, we will end the procedure. In between, we have to do what we have discussed in the life cycle of a cursor. We need to open the cursor. So why should we explicitly open the cursor? Because okay, since we are ready to execute something, then only we have to bring whatever the uh, data that we wanted to operate into the memory, right? So it is obvious that we have to open the cursor only when we are executing it in a procedure. So whenever the procedure is active, so so we say open the cursor, and then it will be opened, and all this records will be fetched into the memory. So now we have access to all the records. So now since we have a lot of records, usually any query would not fetch a single record. It will have multiple records. So to iterate over multiple records, we are going to use a loop statement. So this is so here I have used something called as so this is a normal loop, because it's not as something like a specialized for loop or a while loop. So this is just a simple loop. So this is somewhat similar to the repeat until loop. So we will repeat whatever the statements inside this loop statement, and we will exit. So okay, so this is how we are going to exit from the loop. We are going to exit when not found. Okay, when not found, what is the state? Okay, not found will be returned by this cursor when it has a no more records to process. So when we have a no more records to process, we are going to exit from it, right? And then okay, so what are we doing in the first statement? We are going to fetch the okay we're going to fetch some records from the cursor, and whatever the record that we have fetched, we are going to place it into our player record, which is of the type record. So since we are going to fetch a record at a time, so we are going to store it in this variable called player record, since both of them are compatible, right? And we'll check if it is not found. No, it is found. So we are not going to make so we're not going to exit from the loop, and then we're going to execute these statements. So this is nothing but, so we are trying to print the player, the okay the player name. So this is how you can print. You can raise a notice to the user and saying player using this percentile symbol. We're defining that some variable has to replace this, and this is the variable that you want it to be replaced with. Okay, then okay, when this loop executes, all of the records will be fetched, and this arrays notice will be done for each and every record. And when a record is not found, it is going to exit from the loop. And then after exiting, we have to close the cursor, since a cursor is actually a memory area. And most DBMS softwares, they don't have an explicit garbage collection sort of thing that we had in Java. So we are supposed to close whatever the resource that we are opening. So we have to close the cursor such that the memory can be reallocated to some other process, and there won't be any sort of a memory leak in the system, right? So this is how we define a procedure. So let's execute the procedure and see how it works. Let's see if it works or not. Okay, I'm going to execute. I said okay, the create procedure. is successful, right? So we are able to successfully create the procedure. Now let's run it. Okay, to run it, I'm going to paste this. Yeah, I'm going to call this procedure get team players, and I'm going to give him the team number one. Right? Is it fine that do we have the team number one? Okay, let me check the team IDs. Yes, we have the team number one, and we are supposed to get MS Dhoni as our output. Okay, let's see if if that's the actual output. Yes, the player MS Dhoni is our output. So since we have raised a notice, so we're getting a notice that player is MS Dhoni. So this is how we use cursors to do some sort of customized operations on the records that are fetched, which may not be possible using a simple select statement, right? So and the next object, okay, the next database object that we're gonna look into is the triggers, right? So I discussed that triggers are the most they are the most important because we have a lot of triggers in any DBMS and enterprise application. There will be a lot of triggers happening at the insert triggers, after triggers, before triggers, right? So we need to see how they work. So in the same way, we're creating a function this time, right? So this function is called check valid runs, and it returns a trigger. So how can it returns? Okay, it returns a trigger by returning a trigger. A trigger is automatically called by the system, so a system needs to know that this function is returning a trigger means it is dealing with a trigger. So this function works. Uh, so this function is working for a trigger, right? So that's how we can understand by this written statement. And we are going to use the language PL-SQL, and we're going to begin. So this is a very small block. So what is it doing? If new, okay, so we came across something new here, so that is new. So what is this new? I think I have discussed about this. So we did learn about something known as magic tables. So magic tables are created for triggers which are either it will be created for event triggers. By event triggers I mean any after trigger or before trigger. So when we are saying that there is an after event and there is a uh, before event, then we need to understand that the state of a table will have two states. It will be, you know, uh, after some operation has happened and uh, before the operation has happened. So in the same way, the database is going to manage this by providing us with two tables, right? With two tables called as new and old. So old table will obviously have the old records in it, and the new table will have the new records. But if you are saying, okay, here you might get it out that I am using the event called before. So if this a trigger is going to be fired before some event, then how can I have a new table? So new table will be populated with the values which are expected to be the output of that statement, right? So it will give us it will provide us with a table that will have the values as if they were inserted, as if they were updated, right? So all of this can be accessed using the new. So I am checking if whatever the value that was updated or inserted into my table, which is actually a future event, I'm actually checking if that run scored value, if it is less than zero, I shouldn't allow that to happen, right? So I'm saying then raise an exception. I'm actually writing exception because this will stop that it will stop this insert or update from getting executed. So since this is an exception, it is going to stop the execution from here. If you are simply raising a notice, it will execute that notice. It will shows a notice, and it will return back to its original processing, which is not supposed to happen, right? So we have used a flow control statement if here. So this is how we write the conditional in a DBMS. So we say if, and we're going to provide it with a sum statement which should return a boolean, and then if it is true, then we're going to do some operations, and we should say end if. Okay, since here we have defined that it returns a trigger, So how can it return a trigger? So since we have one of the trigger object new, and this new is actually supposed to be the final state of the table, so, right? So we will be returning the new as we are supposed to return a trigger object, right? So this is the function. Okay, let me execute this function. Yeah, the function is created. So let me explain this trigger, what happens. So to create a trigger, we say create trigger, validate runs, right, before insert or update on player stat. So on this table called player stat, if I'm trying to insert or update, even before I'm able to insert or update, there will be some procedure running. So what is that procedure? It is called as check valid runs that we have defined earlier. So we say execute the function check valid runs before insert or update on player stat for each row. So this is interesting. Oh, okay. Why should we explicitly say for each row? Because insert and update statements are usually so they are a statement level triggers. That means it is not a case that the DBMS works it for every row. Yes, it works it for every row, but whenever an insert is actually applied on the resource itself, it is going to be triggered. But we are saying no, I want it to be executed for each row, not for each statement. So we are defining it to be more granular, right? So this will work for each row. So for each insert, for each update, it should work, right? So we have defined it. Okay, let me run this. Okay, it says it's already exists, right? Okay, I can just create or replace. So the trigger is created, right? Yeah. So how can I run this trigger? So there is something that I should disclose, that there is no way we can run a trigger. A trigger is cannot a triggers cannot be called by anyone. Also, they have to be called automatically, and they will be only dependent on the event. So if the event never occurs, so there is no way a trigger will be fired at any stage in the database system. So we should write triggers only if you think that okay, some operation might happen. I have to disclose some sort of statements for the error control. Then it is the case where you use triggers. Okay, let's try to insert something into this a player stat table, which is which is illegal. So I'm trying to insert. Okay, I'm trying to insert a value called a -10 into this table. So is it illegal as per the definition of the table? It is legal because it is still an integer, and since we didn't have any uh, constraints on the table, so it will be allowed. But as per the business logic, we know that we cannot have the value of runs as negative. So we have defined our own trigger, and we will check if it's a valid thing. Okay, let's try and insert. Okay, let's try to execute the statement and see if we get any kind of an error. Yes, it says there is an error that runs code cannot be negative. And why did we get this? It is because the context is that PL-PGSQL function check valid runs has raised this issue. So this function was called. So how was it called? I didn't explicitly say, okay, I want this function to execute. Then it was called internally because of this trigger. So this trigger valid runs is going to manage will be called whenever something happens on this table. And since this condition has happened, right? So the before insert on this player stat, so that's what we have done. So because of that, it got fired and this got executed. If okay, what if I say I don't want to insert, I'm gonna do some sort of delete or some other statement, then it would execute fine, because we didn't define a trigger to work that way. So we can say delete from player stack where player id. I'm going to delete the 101 player. So will it throw me any error? No, it was able to delete that because there is no a trigger happening. Even if there is a trigger, and that a trigger, if it's okay, if there is no problem with that, then if there is no problem, then our statement will execute fine. But whatever the function that is trying to check for errors, which is trying to check for validation, it will only make sure it will only happen if something wrong is supposed to happen, right? Okay. So I think that's all about the PLPG SQL. We have discussed four objects. We've seen the stored procedures, functions, triggers, and cursors. So it's all about the DBMS playlist, and I'll get back with another playlist.